In the industry, there are two methodologies for well log interpretation. First one is DETERMIN, which is used to generate deterministic individual modules, including the volume of shale, porosity, lithology, and fluid saturation. This method considers only lithology of the rock. Second one is multiple mineral, abbreviated as multimean. It's used to make petrophysical model using a wide range of well data, a combination of logs and cores. It's a faster way and time-saving approach. It also considers minerals in the calculation, unlike the DETERMIN method. There are some steps you need to carry out before start of log interpretation. These steps include two types of data process. The first one is Precalc, which is the module that calculates continuous curves of formation temperature, pressure, mud resistivity, mud thickness, salinity of mud and mud filtrate, conductivity of flushed and unflushed zones, as well as the photoelectric cross-section. All these parameters will be used throughout the petrophysics module and within the environmental or borehole correction, which is the next necessary process that you need to take. It's defined as a group of modules used for correction of raw wireline log data for the effect of borehole conditions. It's based on digitized borehole correction charts or coded algorithms provided by wireline logging contractors. However, in our exercise, we won't do environmental correction as no bad borehole conditions observed or detected. So, why do we need Precalc? Precalc enable avoiding the impact of mud cake on environmental correction because mud cake thickness measured from porosity logs such as neutron density and resistivity log is commonly different. So this process create mud cake thickness curve for both tools. Second one is mud resistivity and mud cake and mud filtrate resistivity are usually measured for samples. So we need a Precalc to change them into continuous resistivity curves, which will be used in the interpretation process. Number 3, to calculate conductivity for flushed zone and unflushed zone from deep and shallow resistivity. Now let's go and start our exercise using GEOLOG software. GEOLOG platform. The name of the project is DETERMIN, and we will do a deterministic log interpretation for only one well, which is C110. It's a vertical well drilled to produce oil from carbonate reservoir. So to create the new well file, we go to click on wells, go to file and new well. Here we define the name of the well, so it's C110. Click OK. And you can see that the name of the well appeared in the wells panel here. Now let's upload the wireline data that we will use for the interpretation. So how to upload the wireline data for C110? So we go to project, and from project window we go to import export and click on file importer, and this is called file importer window, in which we will display the wireline data of the well. So we go to small square here on the right, click and go to the directory where the wireline data file is saved. So go to D, C110 well data. It's saved in the last file, so we display all the files. Click on the file and open. Now you can see here the name of the well, type of the set, which is a wireline, the reference, which is depth, the unit of the vertical depth is feet, top of logging interval and bottom of logging interval, and sampling rate, which is 0.5 feet. To display the logs available in this data set, go to Logs tab, click on it, and here you can check all the available logs with their general data like full name and unit. You can also select the logs that you need for your interpretation and discard the others. So when you are done with the data check, you can click import. Now well data have been uploaded, so let's go now and check by going to wells. Let's minimize this window. We go to wells, file, open wells, we drag C110 and click OK. To show the wireline data that we have just imported, we go to data, text, and new text. Section appears. In this section you can see the well header data and the uploaded wireline data. Go to logs tab, click to see all the logs available for interpretation. Check the maximum and minimum, top and bottom of each record. Now let's start the first step of deterministic log interpretation, which is a Precalc. In the text section window, go to Precalc in the processing pan on the right side and double click. Precalc process should provide us with outputs necessary for interpretation, and this includes logs such as the formation temperature, formation pressure, mud resistivity, mud filter resistivities, and others. These results depend on the input data that we should provide in the orange section, which is special for constant values, beside input logs in the aqua color section. Precalc will import log data automatically from input set, which is a wireline, and results will be placed in the output set that you can either create with a new name or select from available sets. So let's make our output set name Precalc. So it's the set where these outputs will be placed. Now let's come to the first row, which is the option for formation temperature. We set value option for formation temperature as TLI BLI, which is abbreviation for top log interval and bottom log interval. For reference, we use measured depth, so we keep it as it is. For mud cake, for resistivity of mud cake, we choose the tool used to record, so it's either SRT or MPT. We leave it SRT. For the option of salinity calculation, I choose Bateman and Conin. There's another module which is Kennedy, but we keep Bateman. We need to set top log interval temperature, which is in this case 70 degree Fahrenheit. Top log interval, it's 3314. Then we come to bottom log interval temperature, which is 140 degree Fahrenheit. Bottom log interval 4087. For option for hydrostatic pressure, we choose mud density. As you know, mud used to facilitate drilling and balance pressure between formation pressure and borehole pressure. The base of drilling mud is water. Drilling fluid density, provide drilling fluid density, it's 8.6. Then we need to input the resistivity of mud sample, which is 0.43 ohm, and the mud sample temperature, which is 80 degree. Okay, it's 80 degree Fahrenheit. Then resistivity of mud filtrate, we need to provide it as well, which is 0.41. Temperature 74. Then resistivity of mud cake 0.48, and temperature for mud cake sample, which is 81. And we provide the drilling bit size, which is in this case 6 inch. All these values for mud filtrate, mud cake, mud sample resistivity, and the drilling of bed size, the drilling fluid density, you can find it in the hard copy of the log header of the well. And you can see that after we input the mud sample, mud filtrate resistivity, mud cake resistivity values, other outputs will be provided with salinity of the mud, salinity of mud filtrate will be provided as constants. Now let's come to the input logs. You can see that the input logs were imported automatically by the software from the wireline set. So we have the depth and the caliper and the density and the photoelectric flux zone resistivity, but there's a problem with the true formation resistivity RT, which the software could not insert. So we need to do that automatically by double click, go to this small square and select wire set and look for the deep resistivity, which is RT, which we have it here. Click OK. Now these are the outputs and everything. We check if everything is okay, then we click start. Now to see the outputs, go to text and you will see a Precalc set was generated. Go to logs tab where you can see that you have generated the continuous logs for reservoir pressure, temperature and the other data. Right after Precalc process, let's start interpretation of the first reservoir property, which is the volume of shale. We will use gamma ray, which is the most common methodology used for volume of shale calculation. So we go to processing window on the right, click determine shale volume and double click gamma ray. Choose the output set where output logs to be stored. These are the output logs that we will get. So we want them to be exported to a determine set. Keep sampling rate for log the finest. In the first row, you choose type of equation from drop list. Type of equation depends on the data quality. In our project, we choose linear gamma ray index. In the second and the third row, we type the gamma ray matrix and the gamma ray shale. For matrix, it's 7. For shale, it's 150. Option to allow call logic, it's no, because we don't have any call in our reservoir. The input log will be a gamma ray which is imported automatically by the GEOLOG, which is its SGR, and the output will be the volume of shale from gamma ray. So after we finished, we click start. Now let's go back to the text section and check our result. And this is the determine set that we have created, and these are the logs of volume of shale that we created using gamma ray log. Let's move to the second property interpretation of the reservoir, which is the porosity. We go to processing window, click on porosity. There are several modules that can be used to calculate porosity, but we will use the most common one, which is density and neutron. Bateman and Conan, double click. From this module, we can calculate both total and effective porosity. So we will do interpretation for both. So choose the output set determine, not wire, because the input data is taken from wire and the output should be stored in determine. So we go here and choose determine, click OK. Choose total porosity for calculation. Type shale neutron porosity, which is 0.2. Fluid density is taken by default 1, so I keep it. Shale density 2.52. Dry shale density 3.1. Formation water density is by default 1, keep it. shale total porosity 0.3. Option for maximum PHI, keep shale reduced, so it will reduce the effect of shale on porosity. Maximum allowed effective porosity is set by default 30%, and the maximum secondary porosity index is 10%. Option to allow bad hole logic. If there are bad hole conditions, you can say yes, and if there is no, you can say no. So in our case, there is no bad hole conditions, so we say no. Option to allow call logic. There is no call in our reservoir, so we keep it no. The input logs are taken automatically from the wireline set. It also used the limited volume of shale that we calculated using gamma ray. You can see that it was input automatically here. These are the outputs that we will get: effective porosity and total porosity. So after we need to make sure that everything is okay, so we click start. Now to see the results, go to text, determine, and you can see that all porosity data is generated. This is total porosity and effective porosity. Let's go to the final reservoir property interpretation, which is the water saturation. Actually, there are several modules for water saturation calculation stored inside GEOLOG. The most commonly used are RSHE and Simandox. RSHE is used in clean formations, clastic and carbonate. When the formation is clean, it means that it's free from conductive materials in the rock matrix, such as clay minerals. When conductive materials are present, then resistivity won't be a function of water resistivity, RW, only. The conductivity will also account for resistivity measurement. So when conductive materials are present in a reservoir, such as shale sandstone or shale limestone, Simandox equation is preferred. However, since we are working on clean carbonate formation, we will use RSHE equation. So double click. So as we did before, we keep input set wire and output set should be determined, where we put our interpretation logs. So we choose determine, okay. You can see that RSHE parameters A, M, N, tortuosity constant, cementation factor, saturation exponent, all were set automatically, and this case is suitable for carbonate reservoir, so I keep them as they are. Option for cementation exponent constant. The option for salinity calculation, as we did before, we set as Bateman and Conin. The option for formation water saturation is measured. I choose measured if it's measured in the lab. If it's not, there are other methods you can use, either measured from salinity or determined from logs. But in this case, it's the value was measured in the lab, so I keep measured. In this row, I put the resistivity formation water RW, which is 0.03. The temperature of the RW value is 135. 133 degree Fahrenheit. You can see here that the input logs were imported automatically, some from determined set, like the total porosity and effective porosity, and others from the Precalc set. We have the flush zone resistivity, but it seems that the software couldn't find the true or deep resistivity, which is RT, so we need to import it automatically. So double click on this square and go to look for the RT. Yes, this one, choose OK. This is the outputs that we will get, which is the total water saturation, and such as total limited unflushed zone or total water saturation, and the unflushed zone effective water saturation, including also the hydrocarbon hydrocarbon total saturation for flush zone and hydrocarbon effective saturation for flush zone as well. So after we make sure that everything is okay, we click start. To see the result, go to text, click on determine, and you will find the output results is stored in determine. We have total water saturation and effective water saturation. Before we display the logs, I want to show you a very important action. Since you have been through different processes windows for each reservoir property calculation, you can save each process window so you don't need to input all the data again. You can do that by going to Values tab in the bottom here, click and go to Save As. So we will save the process window for water saturation, Save As. We put the name of the process window. Let's process window, say SW. SW process window, and you click Save. Close it. Go to Porosity. Do the same with Porosity. So Save As. Say total porosity. Process window, save. Volume of shale, we do the same, save as. Process window, and save. Close. Go to Precalc, save as. Precalc process window, sorry, and save. Suppose that something happened in the process window. Let's say the data disappeared under any circumstances, and we don't have time to get all the input all the data again. So we can restore back the saved window by going to Values, Restore Previous. I can see now what happened. Or you can also use Restore to take it directly from the saved version. Now let's go and see how we can display the output logs. We go to Wells View section. We go to under Views, Layout, click New Layout. Now Layout window open. Here we can display project logs. On the left side you can see the depth scale column. The scale is in measured depth. We can change the setting by showing the layout properties window. Just double click on the head of the depth column, and from here we can change the depth reference by clicking on the drop down menu. We can change from measured depth to TVD, subsea, or anything else. Usually we need TVDSS when we are dealing with horizontal wells, but since we are working on vertical well, we keep measured depth. After we set up the depth reference for our project, we start adding the logs. We can do that by going to Insert, Wireline. Now you can see that a new log track showing next to the depth column. We go to Insert, and now we have the log. We can choose the log that we have generated. Okay, we don't have to show the the input log. We want to show the output logs. So let's go to Determine Set, and we choose the first one, the volume of shale. Click on volume of shale and click OK. Apply. Now we have the curve that represent the volume of shale along our reservoir. This is the scale from left to right, from 0 to 1. You can swap or change the scale direction from the arrow icon here. You can change also the color, and you can also do some shading. Okay, in case in volume of shale we can do shading to the left and set a color template, or let's choose the template, the common template for shale. So let's say shade, let's set shade left to the left limit, and we use the appearance, not color. We want to use fill, and we look for clay. Yes, this one. Okay, click apply. Now we apply the template that represents the shale. Now let's go and show another reservoir property, which is effective porosity. So we go to determine set, choose effective porosity, click OK. Let's set the scale from 0 to 0.35. Click apply. Okay, we want to put it in a separate wire line, so we insert a new track. Okay, and you can drag. We can drag. Okay, let's see. Okay, we can drag porosity log from here to the new track, and this is our effective porosity log. The scale is reversal to the volume of shale. We can swap it as we said before. Click apply. Yes. Now let's insert the last one we calculated, which is the water saturation log. So we say insert wire line, then insert log, then look for the water saturation. Let's choose the total water saturation. Okay, apply. We have the scale from 0 to 1. We can shade to the left. We can shade the left side of the curve, so it symbolizes or indicates water. So we go to right limit shading, to right shading, and choose color blue. Apply. And for the left shading, we can put green to indicate the hydrocarbon. Green. Yes. Right. Next video we will learn how to quality control our results. As you know, doing log interpretation and getting outputs is not the end. We need to make sure that our interpretation is robust, so to be reliable for further analysis, or to be input into 3D model. Thank you very much for watching. I hope that you learned how to do deterministic log interpretation using GEOLOG software. So thank you for watching, and keep learning.